Hello everyone. Now let us get into the core part of fluid power system, that is hydraulic circuit design and analysis. So this is a major section in module 3 in the subject 17 ME 72, that is hydraulic circuit design and analysis. So before getting into this particular topic, we have to recall plenty of things because this is the application part wherein the entire study whatever we have done so far will be accounted for. Okay, so we have an important thing to be remembered here. So first one being the symbolic representation of all the components, because since we are going with the adaptation of all the components to form a hydraulic circuit, so we have to remember the entire symbolic representation of all the components as well as the auxiliary devices. Okay, so to brief about this, we are going to deal with something called as hydraulic circuit. What is the hydraulic circuit? It is the set of or the group of components that are arranged in the hydraulic circuit to perform a particular task. So since we are targeting a particular task here, we have to understand the representation or the symbolic representation of each of the components, as well as the working knowledge should be known to each and every person who are going to deal with the design and analysis of hydraulic circuit. So that is what it is mentioned here, basics of working knowledge on various hydraulic components, because since it is a complete circuit, if we don't know the actual working principle of each of the components, so the fitment of components in the array or in the circuit becomes a problem. Hence, we have to even know the basics of the working principle. Okay, so here in hydraulic circuit and design, hydraulic circuit design analysis part, so we have different circuits to be designed or studied and assessed based on the particular application. Before that, okay, so we shall have a recalling of all the components symbolic representation, which is shown in the figure now. Okay, so you can observe here, so there is a symbolic representation of the direction control valves, the pressure control valves, the flow control valves, as well as the basic symbolic representation for different types of the pump, the filter, tank as such. Okay, so you can just take a minute of time to look at all these symbolic representations before we are going to start with this particular topic. Hope you people have just gone through the symbolic representation of various components. Now let us go with the simple representation of hydraulic circuit that deals with controlling of a single acting cylinder. Okay, see, the basic components in any hydraulic circuit goes with the reservoir or the tank, followed by the filter, followed by the pump, followed by the direction control valve, pressure valves, as well as the actuator. So it is a sequence because each and everything has its own significance. But if there is a need of any particular variation in the position, so we are going to understand it stage by stage in this particular topic. Okay, let us go on with the first one. So if you just look at this, it is as simple as the first diagram what we have studied in fluid power system, that is basic components of hydraulic system. So there we have written the representation of the entire circuit here. Here we have taken only the symbolic representation to deal with the hydraulic circuit. Okay, so you can observe here the major purpose is to control the single acting cylinder. Remember one thing, when we go with the term called as single acting cylinder, there will always be a control of one action of the movement of actuator using the pressurized fluid. So basically it is the extension or carrying the load or bearing the load structure. Okay, so here what happens, you can observe here in the actuator, so we are going to have the supply of fluid on one particular side so that the extension is achieved. So regarding the retraction, it is spring assisted. So this is the beauty of understanding the fluid power system or the hydraulic circuit here. Okay, so this is to be a very common sense. That is what we said. So you have to know the basics of working knowledge of various components, means to say that how actually it is going to be considered in its working. Okay, so here as it is being described, so I have given the naming for different components here, but stage by stage, by looking at it, we are supposed to be in a position to identify what type of component or which component it is being used in the entire circuit. Okay, so basically, so we are going to take the basic fundamental circuits here, and upon which the multiplication of its the same circuits over the applications can be dealt later. Okay, so observe here from the tank, so the fluid is being taken by the pump through the filter. So here the filter traps the contaminants present in the oil which is present in the reservoir or the tank. So from the pump, the fluid is transferred into the direction control valve. Here, whenever we go with the circuit, we have to study how to read the position of the direction control valve. See here, as we know, we have two envelopes here. So means to say that how many ports here? 1, 2 and 3. So it is 3 ports, 2 position, that is 3 cross 2 valve here, direction control valve. So as it is being represented here, so this is manually operated direction control valve. Okay, so here the valve works at 2 positions. One is at the position 1, wherein there will be a flow from pump port to the system port. Okay, observe carefully here. We have represented the fitment to the second envelope. That doesn't mean it operates only in the second envelope. It means to say that it operates even in the first envelope as well as the second envelope. Okay, so from this particular up to direction control valve, whatever we fit here, this accounts for each of the envelopes or each of the positions at which the direction control valve is being considered for, or the entire operations of that particular actuation system. Okay, so what happens at the first position, there will be a flow from, so I haven't mentioned the term called as PABT here because it is all studied in the previous session itself. Here it is to be the entire representation. By looking at it, we are supposed to be addressing the entire flow. Okay, so from the pump, there will be a supply to the port, the system port here. So that system port is nothing but this particular opening provided in the actuator. Okay, at that particular point of time, the tank port will be under cut-off condition, that there will be no flow of fluid taking place from any system port to the tank port here. Moving on to the second position, what happens? Okay, second position is the retraction now. So whatever we have represented here, it is the extension. Okay, so what about the retraction? During retraction, when you stop the supply from the pump, that is cut-off condition here, we have stopped the supply from the pump here. At that particular point of time, what happens? The fluid which is present here in the actuator from the system port should enter into the tank port because it is subjected to the spring pressure which is compressed during the extension. So thereby what happens? During retraction, the fluid which is present in the actuator will come from the system port and enters into the tank port. Then what is the role of the pressure relief valve here? So the role of pressure relief valve is such that the fluid which is flowing from the pump into the system, if the pressure of the fluid exceeds the system pressure or exceeds the limit pressure, at that particular point of time, the pressure has to be removed from the fluid so that only optimum or the desired set pressure of fluid reaches to the actuator and leads to the performance of the actuator. So hence what happens, so the pressure relief valve is considered here, and it is commonly observed in almost all the circuits wherever we take the hydraulic circuit design and analysis, because it is a main component which leads to the absorption or relieving, removing the excess amount of set pressure which is more than the set pressure. Okay, so that is where you are going to control the single actuating or single acting cylinder. Okay, so moving on with the next one. So again the same concept of working principle here, but we have two changes. We have the actuator which has double acting in the sense both the action of extension and retraction will be controlled by the pressurized fluid. So here if you observe the direction control valve, we have 4 ports, 1, 2, 3 and 4. Okay, that is pump port, tank port and 2 system ports. So number of ports is 4. What is the number of positions? So we have 3 envelopes, 1, 2 and 3, means to say that the entire actuation is considered in 3 positions. So hence, so this is 4 cross 3 direction control valve. Again, you can observe here we have a manually operated lever system representing the functionality of direction control valve on both the sides, and we have a spring assistance here. Okay, so once we go with the positioning understanding, we'll understand why the spring is being added here. So it is manually actuated 4 cross 3 direction control valve, or directly we can say it as a 4-way valve. Okay, so here observe again the same additive, same circuit principle here. So we have a tank, we have filter, we have pump, we have pressure relief valve. Okay, so we have direction control valve, we have the actuator. So here it operates in 3 principles now. Okay, since we are supposed to understand the 3 positions of its working, so what is the first condition? At the first, okay, so the entire system will be attached to the direction control valve. At position number 1, what happens? The pump results in the flow of fluid from tank through the filter by trapping the contaminants. There will be a highly pressurized fluid entering into the direction control valve. Meanwhile, if the pressure of the fluid coming from the pump is approximately lesser than or equal to set pressure, then the same amount of pressurized fluid will be sent into the direction control valve. If the pressure of the fluid exceeds at that particular point of time, the pressure relief valve will be actuated and results in removing the excess amount of fluid into the tank. Thereby the pressure reaches the actuator with the set pressure. So thereby what happens? It enters into the direction control valve. But entering of fluid into the direction control valve happens in 3 stages that results in the working of double acting cylinder. So at the first position, what happens? There will be a flow from pump port to the system port, that is system port here, that leads to the extension of actuator. Simultaneously, what happens when there is an extension of actuator taking place here? Okay, that is when there is a flow from pump port to the system port, then from the system port, which is on the other side, that leads to the retraction. So the amount of fluid present in this particular area, that will be sent into the tank port here. See here, there is a supply from pump port to system port and from system port to tank port. So that happens at the first position. Coming to the second position, what happens? Coming to the second position, it is center of condition, means to say that there will be extension and the piston or the entire actuator will be locked at one particular position. So to lock the piston at one particular position, you are going to take the assistance of spring here. So that is why we are going to represent the direction control valve with spring assistance. Okay, thereby what happens? Okay, that comes the third position, that is retraction. Actuate, stop, retract. Okay, so extend, stop and retract. So during retraction, what should happen? You have to start the supply of fluid from the other end of the other end in the actuator, so that leads to the movement of piston and the piston rod from the extended position to the retraction position. So thereby what happens? There will be a supply from system port to the next system, that is this particular point. So that leads to the retraction, and followed by what happens? There will be the amount of fluid which has resulted in the extension at previous position. That amount of fluid will be sent into the tank here. So this is how you are going to control the double acting cylinder. The only thing is difference between single acting and double acting is, in case of single acting, we are going to control only the extension. The retraction will be by any kind of means like spring assisted as here. Whereas in case of the double acting cylinder, so you are going to control the extension and retraction both by the use of pressurized fluid. Okay, so here it is 3 positions direction control valve that leads to extension, hold the piston at particular position, okay, then retract. Okay, so this is how the double acting cylinder is going to be considered or controlled. The next type of circuit what we are going to study is regenerative circuit. One of the major agenda of concentrating on regenerative circuit is to speed up the extending speed of the double acting cylinder. Means to say that when there is extension being considered in the double acting cylinder, how to increase the speed so that the extension is done at a very faster rate in the entire circuit. Okay, so here, so the entire system remains same here. There is a tank, there is a filter and the pump. So once the pump starts its operating, thereby what happens, it takes the fluid from the tank through the filter by trapping the contaminants, and with an increased or with respect to the set amount of pressure, the pump leads to the entry of fluid into the direction control valve and thereby to the actuator. So here again we have 3 positions now and 4 ports, hence it is 4x3 manually operated direction control valve here. So here what happens, at the first position the flow from the pump leads into the system port, that leads to the extension. Okay. Meanwhile there is a supply from system port to the tank port here. Okay, so if I take this as system port A and system port B here, at the first position what happens, see the supply will be from pump port to the system port, and there will be supply from system port B to the tank port. In the second position, so this is the major difference wherein we have to concentrate on. In the second position, the system port B is blocked, means to say that you are not going to have any passages between system port B and the direction control valve, because the direction control valve will be blocked using a screw threaded nuts or as such simple mechanism. Okay, so thereby what happens then, at that particular point of time there is no supply. Moving on to the third position. Okay, when the valve is considered with the third position, what happens here is that there is a supply from the pump port to the system port B, as well as there is a supply from system port A to the tank port. So this is what the condition has been considered. Now what happens, that this particular condition of pump port to the system port and system port to the tank port is resulting in the retraction. But what is the use of regenerative circuit? It has to speed up the process of extending. Thereby what happens, now we have to concentrate on the entire representation here. So here, whatever the way in which the retraction of retraction action in the actuator is being considered, so that retraction along with the tank port here, okay, there will be a bypass supply from the system port B to the inlet here. So you can observe the flow here, QR is the return flow rate, QP is the flow rate from the pump here. So there will be the return flow rate of the fluid which will be bypassed along with the entry into the tank here. So that will be bypassed to enter into the inlet, that leads to the entry into the direction control valve, okay, for the next operating cycle. That is the next operating cycle, in the sense the next operation is extension. Thereby what happens, this QR, that is flow rate in the return fluid, along with QP leads into the next cycle of extension at a very faster rate. So there is huge amount of differences in the first cycle to the next cycle. So thereby it continues to operate, that leads to the highly speeding up of the extension of the actuation medium in the double acting cylinder. Okay, so this is where the regenerative circuit is going to be considered. The only thing is that in the second position the entire system port will be blocked. Thereby what happens, there will be a supply of fluid from the blocked region into the inlet, and thereby in the third position the retraction of fluid is achieved through the supply from pump port to the system port B here. Okay, at the same time what happens, there will be supply from system port A to the tank port, because you have to retract the piston in the actuator. So thereby what happens, this leads to the concept of increasing the speeding up of force once there is a bypass supplied here, okay, for the flow of fluid to enter into the inlet of the direction control valve, that leads to the extension in the next working cycle. So thereby what happens, it receives additional amount of flow rate that leads to the speeding up of the extension in the next working cycle. So this is about regenerative circuit. Now let us take 3 more circuits in this study. The next one being pump unloading circuit. This type of circuit is considered when we have to unload the supply from the pump, when the pump has resulted in the extreme extension in the actuator. So you can observe the content here. So the additions to this is one particular valve, that is check valve, which is being considered in the entire circuit. So here what happens, again we have 4x3 direction control valve manually operated for a double acting cylinder. So we have a supply from the pump, wherein it takes the fluid from the tank through filter by trapping the contaminants, and thereby, see, this particular symbol leads to the entry of fluid into the direction control valve. So if you refer this particular symbol for check valve, you will get into know. So this is the allowability of fluid to enter into the direction control valve, whereas the fluid flow is not allowed to enter into the pump return back. Okay, so the check valve results in the flow of fluid from pump to the direction control valve here. Okay, so here what happens, at the first position there will be a supply of fluid from pump port to the system port and system port to the tank port. So this is the system ports A and B here, and from pump there is a supply to the system port that leads to extension, and thereby what happens at that particular point of time, the fluid which is present on the other side of the piston will be sent out from the system port to the tank port. So that happens in the first position. Moving on with the second position, what happens? It is off condition. So here it is center off condition, means to say that there is no flow from any of these ports to any other ports. Moving on to the last port here, what happens? At here in this particular position, there is a supply from pump port to the system port B, and there is a flow from at that particular, that results in the flow from system port A to the tank port, that is during the retraction. But here we are supposed to concentrate on the extension of fluid from the extension of the actuator due to the flow of fluid. Okay, so here what happens, when there is an extension taking place, when the piston has reached the extreme position, at that particular point of time what happens, this particular check valve objects the flow of fluid which is flowing from the pump port and thereby unloads the flow. Hence this is considered to be the pump unloading circuit. Okay, moving on with the next one, it is the double pump hydraulic system. So this is basically considered in sheet metal operations such as punching operations. Okay, so sheet metal punching operation is the application here. So here we have the availability of two pumps, low flow pump and high flow pump here. Okay, in case of high flow pump there is a low pressure line, whereas in case of low flow pump it is the high pressure line. So here at this particular study we are supposed to concentrate on two additions here. One is the check valve, two pumps in line, whereas the unloading valve here along with the simple pressure relief valve. Okay, so here what happens, so this is basically when it comes to the length or the actuation in which the entire system is to be concentrated. Okay, so during punching operation, so at the end of this particular piston rod there will be a mechanism attached wherein which that leads to the punching operations on the sheet metal. So thereby what happens is that we are again supposed to concentrate on both extension and retraction here. So here during extension and retraction, the major application of this double pump hydraulic system comes into picture to eliminate the requirement of highly expensive high pressure pumps, which leads to the punching operations here. Okay, so thereby what happens, we have two pumps here in line. So basically when we go with the consideration here, so it is the flow of fluid from the pump that takes the fluid from the tank by trapping the contaminants through filter. Okay, so here what happens, so we have to consider the two considerations when we go with the punching operation. That is almost at the end of punching operation, that is the extension, and the next operation is to punch the given sheet metal. So external amount of energy is required not only for the extension but also for the application of load to punch the given sheet metal. So hence both the pumps leads to the concentration of that particular part in the actuator. So again in the first position there will be a flow from the system pump to the system port A and simultaneously from system port B to the tank port. In the second condition, so it is center off condition, there is no flow taking place, hence it is the waiting time or the delay time in the operation of the valve. Okay, next comes the third position wherein there is a flow taking place from system pump port to the system port B and from system port A to the tank port, that is in the retraction. So here what happens, first of all there will be a flow from high flow pump that leads to the extension of the movement of piston in the actuator. Thereby once it leads to a particular extension, the additional amount of pressure that leads to the actual punching operation, that will be taken care by the supply of low flow pump that will be resulting in the high pressure of fluid which is entering into the system. Here the presence of check valve will be such that when there is a high pressure flow line with high pressure fluid flowing through the line into the actuator, that should not enter into the line at which the low pressurized fluid is being entered into the system, that has led to the extension part. Keep in mind, extension is one thing, actual punching operation is the additional stuff. So extension is resulted due to the high flow pump with low pressure, whereas actual punching operation is due to the high pressurized flow taking place from low flow pump here. So that particular high pressurized flow should not lead to or enter into the line wherein which the high flow pump is resulting in the flow. Hence, we use the check valve to avoid the mixing up. Okay. So meanwhile, when there is a flow from low flow pump into the actuator, this unloading valve results in the unloading of the supply from the high flow pump. This is to be remembered. So this unloading valve result in the unloading of the supply from the high flow pump when there is a supply from low flow pump into the actuator, that leads to the operation called as punching operation. Okay. Moving on with the last part of this particular session, that is counterbalance circuit. Okay. We have studied the counterbalance circuit when we have taken up the pressure counterbalance valve in this study. Okay. So here the major agenda of counterbalance circuit is that it has to retain the position of the actuator in the vertical actuator, the position of the load, due to which may be resultant into the downward movement, maybe due to the extensive amount of load present or due to the gravitational force. So in order to retain the load in the vertical position over a period of time, we are going to concentrate on counterbalance application. So here in this particular circuit, see, this entire zone represents counterbalance valve here. So if you just remember the first session, first part of today's session, wherein different symbolic representation is being considered. So this particular unit represents counterbalance valve here. So here the direction control valve is of bit speciality in its case. Okay, so it is a 4x3. So we have 3 positions, 1, 2 and 3. We have 4 ports. Okay, it is 4x3 solenoid operated. You can observe here it is solenoid operated. Okay, it is open centered direction control valve, means to say that at the center position, as in case of other different types of circuits what we have studied, it is center off condition. Whereas here in the counterbalance circuit, it is open centered application. Okay. So if you observe here, these 2 additional entities represents the solenoid actuated valve. So again, the system goes in the same platform. So we have a pump that receives the fluid from the tank through the filter by trapping the contaminants, and if the pressure of the fluid exceeds the set pressure, then the pressure relief valve results in the removal of excessive amount of pressure, and that leads to the set pressurized fluid enter into the direction control valve here. So here what happens, at the first position there is a supply from pump port to the system port and system port to the tank port here, that is extension. Remember here, so this is extension, this is retraction. It depends on the type of loading condition. Okay, so here what happens, the load is vertical now. Okay, if you want to keep it upright, that becomes extension. If you want to lower it down to its original condition, that becomes retraction. Okay, or else, okay, if you want to pull the load to the downward direction itself is the activity or itself is the task, then that becomes extension, and bringing the piston to its position becomes retraction. So it all depends on the type of activity here. Okay, so here in the first position there is a flow from pump port to the system port and system port to the tank port. In the second position it is open centered solenoid operation, means to say that here there, as in case of the other types of valve, it was center of condition which was resulting in the delay, but here it is the open centered valve, and therein where the counterbalance valve comes into picture by holding the load at vertical position itself. Okay, you can just see here. So here you can observe in the second position, so there is a flow from pump port, okay, into the system port. So this is the allowability of fluid to flow. So see here, whenever we have a circular symbol, that is the objection. If we have a flow with a V shape, okay, so that results in the allowability of flow. So there will be a flow of fluid through the check valve here, and that particular flow results to accumulate at the bottom side of the piston or the piston rod end, so that creates a pressure, and keeps the load in upright position or in the vertical condition. So that is in the second position. Meanwhile, what it is being happening here, the fluid that is resulting in the lowering of the load which was present on the piston end, that fluid is being taken into the tank here. So observe carefully, in the second position there is a flow from pump port to the lower surface or the lower opening in the actuator to retain the load in the vertical condition, and meanwhile what is happening, the fluid which is present in the piston end, that will be taken in the second position itself into the tank, and thereby at the last position, that is in the third position, so we are going to give supply from pump port to the system port B and system port B to the tank port. So this is where the counterbalance valve go with its operation. So you have to concentrate on the second position, and this is the area wherein complete counterbalance valve or the counterbalance type of pressurized valve can be considered. So this is for today's session. Thank you.